This is a review before we start Chapter 3, Section 1. This is solving one-step equations. We'll start with some vocabulary. Solution of an equality. The solution of an equality is the value or values of the variable, which remember is just a letter, that makes the equation true. Next we have equivalent equations. Equations that have the same solution or solutions. And then we have four properties here. These are really important. They're the basis of what we're going to be doing in all of Chapter 3. The first is the addition property of equality. That's where you have something like A equals B. So then we know that if we add the exact same thing to both sides, plus C, they're still going to be equal. Subtraction property of equality is similar. Again, if A equals B, then if you subtract the same thing from both sides, they're still equal. Same thing with the multiplication property of equality. If you have two things that are equal, and you multiply both sides by the same thing, they're still equal. And finally, the division property of equality. If you have two things that are equal and you divide both sides by the same thing, they'll still be equal. So real quick, I'll just show you an example of this. For instance, for the A equals B part, we would have something like 3 plus 5 equals 8. So then if I add 4 to both sides, then they're still equal. 3 plus 5 is 8, plus 4 is 12, and 8 plus 4 is 12. So since I'm adding the exact same thing to both sides, the left and right side are still equal to each other. Okay, let's look at some examples. We have one more vocabulary word, inverse operation. It says operations that undo each other. That's our whole premise here. That's our whole thing we're going to be working off of, is we're going to try to undo operations. So look at what's happening to your variable and undo it. So in A, we're adding 8. So the opposite of adding 8 would be to subtract 8. The inverse operation of adding 8 is to subtract 8. And here we're using that subtraction property of equality, where we have these two things that are equal, x plus 8 equals 12, and we're doing the exact same thing to both sides. That's the subtraction property of equality. So we bring down our x, nothing happened to that. Plus 8 minus 8. They are additive inverses of each other. It's 0, so they basically cancel each other out. Bring down your equal sign. 12 minus 8 is 4. Therefore, x equals 4. And you can see that if you put here 4 for x here, 4 plus 8 would in fact give you 12. So that is the solution to our equation. On B, again, we want to do the inverse operation. What's the opposite of subtracting 7? So we're always doing the opposite of whatever's happening to our variable. The opposite of subtracting 7 would be to add 7, and remember you have to do it to both sides. So that would be the addition property of equality. We have two things that are equal, so we can add the exact same thing to both sides, and they'll still be equal. So we bring down our y, negative 7, positive 7, they're additive inverses of each other, which means they cancel, equals 2 plus 7 is 9. Therefore, y is 9. And again, you can see if you put 9 in for y, 9 minus 7 would in fact give you 2. On C, solving for A. So again, we're doing the inverse operation. The opposite of adding 6 to A would be to subtract 6 from both sides. Subtraction property of equality. Since the left side equals the right side, if I do the exact same thing to both sides, the two sides are still equal to each other. So we bring down the A, plus 6 minus 6, additive inverses, that gives me 0, so it cancels. Bring down your equal sign, negative 4, and negative 6 is negative 10. And again, you can see if you plug that in, negative 10 plus 6 would give you negative 4, which is the answer. On D, again, we're doing the inverse operation, Z minus 4. The opposite of subtracting 4 would be to add 4 to both sides, the addition property of equality. So bring down your Z, negative 4 plus 4 is 0, equals negative 8 plus 4, so they're opposite, or they don't have the same sign. So remember your rules of addition. If they have different signs, you have to subtract and take the sign of the larger digit. So 8 minus 4 is 4, and 8's bigger, it's negative, so my answer is negative 4. Again, you can plug that in. Negative 4 minus 4 would give you negative 8. On E, the opposite of subtracting 7 would be to add 7 to both sides. That's the addition property of equality. Those are additive inverses of each other. So Q equals negative 5 plus 7. Again, these have different signs, so you have to subtract. 7 minus 5 is 2. 7's larger, it's positive, so is your answer. And last one on F, t plus 3 equals 5. The opposite of adding 3 would be to subtract 3 from both sides. I hope you're noticing that every time we have to do the same thing to both sides of the equation. You have to be fair in algebra. It's all about keeping the two sides even and equal and keeping everything fair. So we bring down our t plus 3 minus 3. Those are additive inverses. Gives you 0 equals 5 minus 3, which is 2. T is 2. And again, you can substitute it in for t and see that it does in fact work. So substitute 2 in for t. 2 plus 3 is 5. And that way we know we found the right answer. All right, let's try some different ones. Now, all of these were adding and subtracting, so let's look at multiplication and division. Again, we're just doing inverse operations. You do the opposite of whatever is happening to x. So here, this is 3 times x. The opposite of multiplying is to divide both sides by 3. And what happens when you divide by 3? Well, 3 divided by 3 is 1, and 1 times x is just x, using the identity property of multiplication. Bring down your equal sign. 12 divided by 3 is 4. Also notice that we used the division property of equality here. We divided both sides by the exact same thing. We're going to do the same thing on B. Here it's negative 2 times y. The opposite of multiplying by negative 2 is to divide both sides by negative 2. Remember, you have to do the exact same thing to both sides to keep it fair and even. Negative 2 divided by negative 2 is 1. 1 times y is y because of the identity property of multiplication. And 14, positive 14 divided by negative 2, they have different signs. So our answer is going to be negative. 14 divided by 2 is 7. And you can do the same thing here. You can plug these in. Negative 2 times negative 7 would give me positive 14. Same thing with 4 here. 3 times 4 would give me 12. On C, the opposite of multiplying times a negative 7 would be to divide both sides by a negative 7. Negative 7 divided by negative 7 is 1. 1 times z is z because of the identity property of multiplication. And negative 28 divided by negative 7, they have the same signs. They're both negative. A negative divided by a negative gives me a positive. 28 divided by 7 is 4. So z is 4. And you can substitute 4 in for z and see it does in fact work. Negative 7 times 4 is negative 28. On D, now instead of multiplying, x is being divided by 9. The opposite of x being divided by 9 is to multiply both sides times 9. Over here, since we have a fraction, I'm going to make my 9 into a fraction, 9 over 1. Now notice, if you remember cross-canceling, that the 9's cross-cancel here. 9 and 9. You can divide both of the 9's by 9 and get 1 for each one. Otherwise, 9 times x is 9x, divided by 1 times 9 is 9, and you still get that 9 divided by 9, which is 1, and so it just leaves you with x. 3 times 9 is 27. Therefore, your answer is x equals 27. And you can see that if you plugged in 27 for x, 27 divided by 9 would give you 3. On E, now we have a negative sign to contend with, so we need to get rid of the negative as well as getting rid of this divided by 7. So the opposite of dividing by 7 is to multiply by 7. But if I want to get rid of this negative sign, I have to multiply by a negative, because a negative times a negative will yield a positive. So since I'm multiplying by a negative 7 here, I'll also multiply my other side times a negative 7, because we have to do the exact same thing on both sides. So the negatives cancel. A negative times a negative gives me a positive. Again, this is a 7 over 1, so you can cross-cancel again, and you're left with simply z equals 5 times negative 7 is negative 35. Last one, F, 2/5 y. So this is a little different. It's not just our variables being divided by a simple number. Now it's 2/5 times y. So usually we say, okay, well, the opposite of multiplying would be to divide, but we know we can't divide fractions. So instead of dividing these fractions, what would we do? We'd have 2/5 divided by 2/5, and you'd say copy, change, flip. So we'd copy the first fraction, leave that alone, just our black 2/5 here, change division and multiplication, and flip the last fraction to 5 over 2. And then what happens? 2 times 5 is 10. 5 times 2 is 10. 10 divided by 10 is 1. And then we just have 1 times y. So we've gotten rid of it that way. So instead of dividing, when you have a fraction times your variable, instead of dividing, you're always going to multiply by the reciprocal being that flipped fraction. So every time you see a fraction times your variable, just multiply it by the reciprocal, and make sure you do that to both sides. So I have 5 times 2 is 10, 2 times 5 is 10, 10 divided by 10 is 1, and 1 times y leaves me with just y. So basically these fractions cancel each other. You can also see cross-canceling, 5 and 5, 2 and 2, everything becomes 1, 1 times y is just y, equals, and then we multiply 6 times 5 halves, so it's 6 over 1, all whole numbers are over 1, and then we can cross-cancel again. So I have the 6 and 2 can both be cross-canceled by 2. So 6 divided by 2 is 3. 2 divided by 2 is 1. And then we just have 3 times 5, which is 15. However, if you have trouble skipping that step, you don't have to. You don't need to cross-cancel. You can still solve it without cross-canceling. If we look here, so this is our answer, but I'll show you that step that we skipped. 6 times 5 is 30. 1 times 2 is 2, and you still get 30 divided by 2 is still 15. So if you're not comfortable with cross-canceling, well then just show this extra step, that y equals 30 divided by 2, and then you can simplify it to y equals 15. All right, that's one-step equations. In 3-1, we'll be learning two-step equations.